Okay, here's problem number 23 from section 3.1. We're given this graph which shows over time the population of rabbits. It seems as though they started out with 1,000 rabbits and they steadily gained to over 2,000 rabbits, and then there's a decline on that blue line. It also shows us the number of foxes. There are very few foxes, and then over time they rise and then they fall. All right. So, first question they ask is, what is the value of the derivative of the rabbit population in 3.1 when the number of rabbits is largest? Well, when the number of rabbits is largest is right here, and we can see that the derivative of that population is 0, or there's at the point where the number of the population is maximized, there's a change in there's a change in the direction of the function. So 0 when population is greatest, and when is it when it's least? Well, it's least down here on this time frame when days equal to 200, and at that point the slope also looks like 0. So it's also 0 when population is least. Question B, what is the size of the population in 3.1 when the derivative is largest? Well, the derivative is going to be largest when the function is at its most positive and most steep. And that looks to be about there, and they've conveniently given us that value. Its population on day 20 is 1,700. And we'll say there that the derivative is largest. Now, when is the derivative smallest? Well, in this case, we mean most negative. So we're going to say that most negative happens, I'm going to say somewhere in here. Or we can also take a look at the derivative of the graph, which happens about there. That's when it reaches the derivative is at its most negative. And when does that happen? It looks to be about 55. So what do we say at, not 55, it's 65. At 65, it looks like our function is about there, which seems to be about 1,200. So at 1,200, and population is 1,200, derivative is smallest.